Today, we're going to dive into a pretty wild idea called UPT, or the postmodern unified theory. It's a theory that asks us to completely rethink the fundamental forces that run our universe, suggesting, they might all just be one thing. So let's get into it. What if everything you've ever learned about the basic forces of physics was really just one side of the story? What if gravity and electromagnetism and all the nuclear forces weren't actually separate things at all? What if it all boiled down to just one? That right there is the core idea of UPT. It proposes that every force we see and measure is just a different expression, a different face of a single fundamental principle, a true unified theory. Okay, so how on earth could that even be possible? Well, to get our heads around this, we first need to learn some of the theory's unique language. Let's take a look at the foundational concepts that everything else is built on. So first up, the theory itself. UPT, the postmodern unified theory, isn't just trying to make a few adjustments to what we already know. Nope. It's trying to build a completely new framework from the ground up to describe every single physical interaction. And at the very bottom of this framework is a brand new particle, the foundon. This is it. The absolute, can't be broken down any further unit of matter. Seriously, think of it like the universe's ultimate Lego brick that everything else is made from. And here's the most important piece of the puzzle. Vacuum intensity, which we'll just call I. I want you to imagine that every single point in space has a number attached to it, a value that describes how much vacuum is there. It's kind of like a pressure reading, but for the vacuum itself. This one single variable is the key to the whole theory. So we've got the building blocks, but what actually makes them do anything? What's the engine that drives reality in this model? Let's take a look. The entire dynamic of the UPT universe, everything that happens, is governed by a very specific definition of energy. It all comes down to the energy that's just sitting there in the vacuum and how that energy wants to behave. And this energy has two main parts, and they're actually pretty simple. First, there's the expansion tendency. All this means is that the vacuum naturally wants to expand. The more vacuum intensity you have in one spot, the more energy is there pushing it to grow. But there's a cost. That's the second part, the distribution cost. Think of this as the energy it takes to make the vacuum distribution lumpy or uneven. The universe then is in this constant tug of war, trying to balance these two things. And from that simple energy balancing act, a mathematical tool called the force tensor just naturally emerges. The easiest way to think of it is like a 3D pressure map. At any single point in space, it tells you all the pushes, the pulls, and the stresses that are happening in the vacuum. So this brings us to the most important point. The source material puts it perfectly. What we call forces are really just expressions of how this vacuum intensity is distributed and the shape of the boundaries between things. That quote really captures the whole idea. All right, so how does this one single mechanism manage to explain all the different forces we see out there in the universe? Let's see how it's all supposed to come together. The whole process is surprisingly straightforward. So picture two of those Fundon particles. They move through space and eventually touch, creating a boundary between them. Right at that boundary, their different vacuum intensities interact. The force tensor then tells you exactly what the push or pull is, right there on that surface. And that interaction, that physical push or pull on the surface, is what we call a force. There's no spooky action at a distance here. And that is the great unification. Uppret claims that whether we are talking about electromagnetism or gravity, or even something like the way water flows, it's all fundamentally the exact same mechanism, vacuum expansion. The only thing that changes is the specific shape and the conditions right at the boundary where the interaction is happening. Now, for a theory this ambitious to hold together, it has to play by some very, very strict and self-contained rules. It doesn't get to borrow ideas from other parts of physics. So let's run through the core rules of the game here. First, every single interaction has to happen through direct contact at a surface. That means no action at a distance. Gone. And this next one is huge. There are no body forces. A force can't just magically appear inside an object. It must come from the outside by acting on its boundary. And finally, every single rule has to be built up from the theory's own basic starting assumptions. So let's step back. What does all this actually mean? Well, if this framework has it right, it means we have to fundamentally rethink some of the most basic laws of physics we take for granted. This slide really puts the two worldviews head to head. Conventional physics gives us a handful of fundamental forces. UPT says, nope, there's just one: vacuum expansion. We're all taught that the speed of light is a universal constant. UPT claims that no wave has a constant speed because it always depends on the medium it's traveling through. And while we use the idea of fields to explain forces acting at a distance, UPT just throws it out completely and says everything happens through direct contact. So to wrap up the UPT worldview in a nutshell, there is only one fundamental force. That force is simply the natural tendency of the vacuum to expand. Every single interaction is a surface interaction, and the things we call physical laws aren't fundamental rules themselves, they're just patterns that emerge from the geometry of all these surface interactions. And all of this leaves us with a really deep question. The search for simplicity and unification is kind of the holy grail of physics. But could it really be this simple? Could all the incredible, mind-boggling complexity we see around us, from the formation of galaxies down to life itself, truly emerge from one single elegant rule about how a vacuum behaves? That's the provocative idea right at the heart of UPT.